exponents and radicals related to one another. So this should be reviewed from 9th grade algebra. Most of this should be familiar, so we should be able to run through it relatively quickly. Okay, next page. I accidentally put the answers in already. Okay, so here are some of our rules. A to the 0 power. What is it? 1. Always? What's 0 to the 0 power? 1. What's macaroni to the 0 power? Do you get my point? Okay, it's always 1. All right, we have common bases, right? What does common base mean? Same variable, a and a. When I multiply common variables, what do I do with their exponents? Add them. Good. So you're going to put in a raised to m plus n. Carrot? Okay. What about down here? AB raised to the nth power. What does this become? Any ideas? What do I have in the parentheses? Okay. When I raise a power to a power, what do I do?
Square.
Yeah, I have a corny way of remembering this. You ready? Go like that. You raise a power to a power, you multiply. Corny, right? It's just the rule, okay? So what's the exponent to this A? What's the exponent to the B? So when you raise a power to a power, you multiply. You have to make sure you take it to the A and the B. So A to the first power raised to the nth is A to the nth, and B to the first power raised to the nth is B to the nth. Okay? So your solution here is A raised to the n. Find n here. And B raised to the n. That's not. Okay? So whatever's in the parentheses, you have to raise both. Are we okay with that? How many of you remember these rules? None of you. Okay, go to the next page. Actually, I don't even know if I can do a... Okay, what about a raised to the negative nth power? Does anybody remember how to get rid of a negative exponent? You are dividing, but what are you going to do to this?
Divide by 1.
Okay, so how are you going to write it?
1 over
Keep going.
an.
Good, a to the n. 1 over a to the n. Perfect. Okay, dividing common bases. What do I do with their exponents? Subtract. So it becomes? Good. A to the m minus n. Are you okay? Good luck. Next page. Okay, nth root is what we're going to talk about now. This is the nth root of a. Does anybody know what we call that little n? We have a word for it. It starts with an I. Nobody? Index. N represents the index. That tells us what root it is. If there's no number there, what's the index?
1, 0, nothing.
Square root of 4. What's it equal? So we were looking for a number that you multiply by itself how many times? So what's the index? 2. Cube root of 27. What's it equal? Because it's 3 times 3 times 3, right? 4 times 4. So the index here, if it's not written, is a 2. Okay? What's the A stand for? What's the vocab word for that? Underneath the radical.
Give us the first one.
R.
Rational.
No? No? Radicand. Very good. Radicand. So the radical is the actual radical. The radicand is what's underneath the radical. Uh-huh.
On the last page, we skipped one.
We did?
Hold on.
Where is it?
All the way down.
A will be raised to the nth is A to the n, B will be to the n. Sorry about that. You got it? Yes?
We get a new projector yet?
No, not yet. Okay, remember, square root has 2 possible roots. Principal root, which is the positive root, and then the negative root. The reason it has 2 possible roots, let's look at square root of 4 again. Tell me the square root of 4 was 2, right? What's 2 times 2? What's negative 2 times negative 2? So the square root could be a plus or a minus, okay? A principal, and then the negative root. Okay. Why do I keep doing it that way? Okay. Square root of 4x to the 6. So when I take the square root, what do I need to do? What am I taking the square root of? Huh? What am I taking the square root of?
4.
4 and? Okay, so can I rewrite it to look like this? Okay? You can pull these apart. You can break them apart into different pieces. All right? So square root of 4. Square root of x to the 6. X to the 3rd. How'd you get it?
Just half that.
Yeah, it's half of the exponent. The other way you can look at it is x to the something times x to the something has to equal x to the 6, right? You guys said when we multiply variables, we do what to their exponents? So you have to have a number that you can add to itself that's going to equal 6, and that's going to be 3. Okay? So this becomes x to the 3rd. Oh, that's ugly. Okay? How'd you do with that, okay? All right, so I want you to try the next one, the cube root of a cubed b to the 6th. See if you